Hello, my name is Balitsky from the Ghent University Department of Civil Engineering, and today I want to give you a quick talk about wave energy, how and why do we model it. So what you see in this picture is that we have various processes that we use numerical models. Now, what exactly we're trying to do, why we're doing it? Well, what we're trying to do is no less than convert electricity from ocean waves. And as you can see in this picture, this involves a lot of various tasks. To accomplish these goals, we use a machine called wave energy converters, and we use things called motion solvers to move them. So what happens when we put a lot of these WECs close together? And why do we need to do it? Well, first of all, we need to do it because a single WEC is too small to individually produce electricity in an economically viable way. When we put them together, it becomes comparable to the size of an onshore or offshore wind farm or a solar plant. But these waves, these WECs, when placed close together, have an effect on the motion of each other and on the surrounding coastline. And these are what are called waveform effects. So in our group at Ghent University, our focus is on using numerical models to model groups of these devices, which are called WEC arrays or farms, with the name depending on the size and on the number of the devices. So as you can see, our focus is on the two models on the right. Now, what are these models and what do they do? The model on top is called a potential flow model, and it is a model which models the interactions close to the devices, while at the bottom you see the wave propagation model, and this is a larger scale model that enables us to model a whole part of the coastline. So we can couple these potential flow models to the wave propagation models, and the result is a more accurate picture of what is happening in both near and far away from the WECs. So on the left, you see an example of a small array of devices, and the yellow areas you see indicate the wave height, increased wave height. The blue areas, decreased wave height. On the right, you see the coastal. On the right, you see the effect of this waveform on the coast, and the blue areas you see is a decrease in the wave height. So why is this important, and why do we need to do it? The important point is that the modification of the wave height close to the devices affects the performance of the wave energy converters, because the wave height, the electricity production is proportional to the wave height, while for the coastal areas, the addition or the removal of wave energy and its redistribution has an effect on various activities, such as, for example, fishing, or tourism, or even shipping. So on this final slide, I will show you an example of the kind of work that we do at Ghent University. What you see is the wave field modified around an array of 6 devices which are placed at the peak at the center of the image. You see that the red areas are higher than the blue areas, so the red areas correspond to enhanced wave height, the blue areas to reduced wave height, and our goal in our research is to find the appropriate area to place the devices, which we would like to place in the so-called red zones, and avoid the blue areas. While at the same time, we would like to mitigate, or we would like the effects far away from the devices to be small. And as you can see, it's a good thing that this modification, as you move away from the center of the model, gets less. In fact, that is what enables our coupling methodology, and enables us to get accurate results. So you might be wondering, because there's a lot of ecologists in the room, if these devices have any effect on marine life. In fact, they do, and you might be surprised that it's been shown that the effect is mostly positive, because marine organisms view these WEC arrays or farms as a kind of artificial reef. However, more studies need to be done, and our group at Ghent University is part of this exciting research that hope to get better results and hope in the future that wave energy will be a viable industry. So I hope I enlightened a bit in this presentation of the work that we do at Ghent. and I hope that wave energy becomes a reality in the near future. Thank you.